This video is on a revision for VSEPR and also shapes. Okay, so if you refer to your textbook, you'll see that VSEPR means valence shell electron pair repulsion theory. And this theory says that pairs of electrons or electron domains in the valence or outer shell of an atom, we usually look at the central atom, they repel each other and will therefore take up positions in space to minimize this repulsion. So it means that they need to be as far as possible to minimize this repulsion. Okay, you can revise that in your textbook. Let's look at how to determine shapes of a molecule. Okay, so first step is we're going to draw the dot and cross. Let's say we're given the question PF3. Okay, so first things first, we're going to draw the dot and cross. So P, look in the periodic table, P has 5 outermost electrons. So 1, 2, 3, 4, 5, and F is from group 17, so 7 outermost electrons. So they're going to bond here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then you count the bond pairs and lone pairs. So in this case, there is, let's say, 1 bond pair, 2 bond pair, 3 bonded pairs. So 3 bonded pairs of electrons and 1 lone pair. Okay, so the third step is to match with the table. We've done that table here. So if you look at the table, you do need to study the table that if you have 2 bonded pairs with no lone pair, it's going to be linear shape, as in like straight. So the angle is 180. So that's as far as it can go. This is to minimize the repulsion. So if there's 3 bond and 0 lone, it's going to be trigonal planar like this. If it's 2 bond, 1 lone, then it's going to be bent or V shape, such as your NO2 negative. We can also call it nonlinear. And if you have 4 bonded pairs with no lone pair, it's tetrahedral. You need to remember the angles, for example, CH4. And if you have 3 bonded pairs and 1 lone pair, it's trigonal pyramidal, such as ammonia. So you have 1 lone here and 3 bonded here. Remember that you need to use triangle like this, a wedge, for the ones coming out of your page and dotted for the ones going into your page. Okay, and if you have 2 bond and 2 lone pairs, it's going to be the same as 2 bond and 1 lone. You're going to get bent shape or nonlinear or V shape, but the angle is different from if it is 2 and 1 here. Okay, such as water. Okay, coming back to our question here, PF3. So you counted there is 3 bond pairs and 1 lone pair. So it looks like ammonia, 3 and 1. So it's going to be trigonal pyramidal. Let's try one that has charge, say SO4, 2 minus. Okay, so sulfur, then group 16, so 6 outermost electrons. 1, 2, 3, 4, 5, 6. And oxygen, that's 4 of them. 1, 2, 3, 4. Okay, I'm going to move the electrons so that I can put a double bond, since we know that oxygen has 6 outermost electrons. And it's going to form a double bond. So I'm going to delete this 1, 2, 3, 4 and place it here. 1, 2, 3, 4. Okay, so I'm going to put in the 6 electrons for oxygen. 2, 3, 4, 5, 6. And for the other two, I'm going to put a negative charge here. So 1, 2, 3, 4, 5, 6. And that negative charge, an extra electron probably came from, say, sodium or potassium or calcium. So I put one extra here. And this oxygen, 1, 2, 3, 4, 5, 6. And also an extra electron that is from either sodium or potassium or magnesium, something from the metal groups. Okay, so now I'm going to count my bonded pairs of electron. 1 bond pair, 2 bond pair, 3 bond pair, 4 bonded pairs. Okay, remember that if you have a double bond cannot be separated like that. So when we have a double bond, we're going to count it as 1 bonded pair. So we have 1, 2, 3, 4, 4 bonded pairs, and there's no lone, so 0 lone. So this shows that it's going to be tetrahedral shaped. Okay, in our drawing here, the dot and cross, it's shown that sulfur has expanded its octet here because there's more than 8 outermost electrons here. Let's count. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outermost electrons. So sulfur has expanded its octet. But let's say if a student decides to draw one that it doesn't expand its octet, so I'm going to delete these. Okay, back to purple. Okay, I'm going to shift the electrons from oxygen back to itself. So it looks kind of like a dative bond. Okay, so if we recalculate this, so 1 bond pair, 2 bond pair, 3 bond pair, 4 bond pairs, we're still going to end up with 4 bond, 0 lone, even if it doesn't expand its octet. So you'll end up with the same answer. It's going to be tetrahedral as well.